Hey everyone. We are finished with our systems of equations lesson, so we're going to be moving on to graphing transformations. Now, a transformation is moving a shape on a graph or a point on a graph anywhere, but not changing the shape. Now, this is one of the most important parts of a transformation. So a transformation moves a shape, line, point, etc., whatever, on a graph without changing its shape. If it changes the shape, if it changes the size, if it changes the way it looks, it is not a transformation. It is something else, and we're going to go over that later in the lesson, but for now, you're just worrying about transformations. So there are three different ways to transform shapes on a graph. The first way is called translation. And this can also be thought of as slide. So you are sliding a shape left, right, up, down, sometimes both at the same time. And then you also have, actually we'll do one at a time. So translation here. Translation is called slide. So let's say we have a graph. I don't know, blah, 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 blah. And let's say that we have a shape that looks like this. Okay. First of all, when you are graphing on when you're graphing a shape, the one thing that you really need to know are the vertices. The vertex, plural of vertex is vertices. So these points right here are some of the most important points that you're going to be dealing with, because the rest of the shape doesn't matter. All you're going to be doing is finding out what's happening to these points, and then you just connect the dots afterwards. So this is what I mean by that. Let's say that this graph is, I don't know, let's make that one there. Okay. So let's say that this top point here is 2, 6. And then this bottom one here is 4, 2. And this bottom one here is 2, 2. All right. I'm going to name this one A. No reason why. I'm going to name this one B for, again, no reason, and C. Now, the reason, there's no reason as to why I named it these. I just chose A, B, and C. It doesn't make a difference. The main reason I'm doing it is because I want there to be no confusion when I am talking about point A, point B, point C. So now that I have all my points, so I would say the step one here would be to identify and label your points. So we did that. That's step one. Step two is to follow this equation. If you can figure out what this equation is and really master how to do this, translation will be nothing. You'll be able to do these in seconds. So the equation here that you need to know is x, y, and then you have this little arrow. You have to draw the arrow. And then x plus h, y plus k. And I'm going to explain what that means in a bit. I'll put this in bold, and I'll put it in red. Why not? So in this case, H represents the horizontal movement, and K represents vertical movement. So when I'm talking H, I mean left and right. And when I'm talking K, I mean up and down. All right? And then let's not bold these. Okay, cool. So let's say that I wanted to move this, I don't know, 3 units up and 2 units down. What I'm going to do here is I am not even going to really look at this graph. I really don't care about this graph. All I care about are my points. And I'm going to use this equation to help me figure out where my points are now. So let's take a look at this. So my original equation here is x, y, arrow, x plus h, y plus k. One thing to remember, when you are graphing, the upwards direction and the rightwards direction, let me draw it over here, these are positive movements. But the downwards direction and the leftwards direction, these are negative movements. So when I'm saying 3 units up, I am doing a positive 3 movement. And when I say 3 units down, that is a negative 2 movement. Down, negative, and then the number 2. Up, positive, and the number 3. So when I'm writing out this equation, I'm just plugging in what they tell me. So I have x, maybe I'll keep it to black. I'll have x, y, to x, and then my my left and right movement. Oh wait, dang it. Let me change this real quick. I just realized it's up and down. This should have been right. 3 units right. Okay, so that will be 3 units right and 2 units down. All right, so let's do this real quick. Let's change that and then put right here. So 3 units right, 2 units down. There we go. So again, my left and right movement, my H represents my left and right horizontal movement. So that means I'm going right plus 3. So right here, I am writing plus 3. For my H, instead of H, I put plus 3. And then for Y, my vertical movement, my K, is 2 units down. That's a negative 2, so minus 2. All right? And so all I do is plug in my points. So if I were to do for point A, I would have my coordinates are 2, 6, right? So that means I'm going to plug in 2 for my x and 6 for my y. So what I end up with is x, y. You always have to write this. You should always start out with this, x, y. You have to do this equation step by step. So you see this whole thing, you have to write this whole thing. This is the translation equation. So xy turns into, now you plug in. So here you have your, actually you can do it even before if you want to. 2, 6, so instead of x you put 2, and then you know that your equation is supposed to be plus 3, so plus 3. And then 2 plus 3, and then your y is 6, so 6 minus 2. So then you end up with your new ordered pair, which I will do in orange. Why not? I'll do it in orange. Your new one is 2 plus 3 is 5. And 6 minus 2 is 4. So that's your new point. For every time that you do a transformation, you're going to rewrite your point and put a little mark on top. This is called prime. So this is a prime. If I did 2 translations to it, if I moved it twice, I would do double prime. 3 times, triple prime. 4 times, quadruple prime. 5 times, pentuple prime. And it just keeps going. But because I only did it once, this is a prime. This is how you differentiate the original shape from the new shape. which by the way brings me to new vocabulary. The two new vocabulary that you need to know is pre-image, which is the shape before any movement. So before you even do anything to it, this is what the shape looked like. And then you have the image, and I'll do that in a different color, blue. So the image is the shape after any movement. So the pre-image in point A's case is 2, 6, represented by A, and the image is A prime with 5, 4. So right now, this is the pre-image, this is the image. So we did it for A, let's do it for B. And if you're kind of already getting the process of this, you can just skip forward to this or pause it and try it yourself. I'm going to go through B, then I'm going to go through C. So for B, the original point is 4, 2. So if I were to use the equation, my ordered pair is 4, 2. And then I do my little arrow. So my x is 4, and I know I'm supposed to plus 3 every time. This is my general equation. I figured this out from what they gave me. So 4 plus 3, I'm going to be plussing 3 every time this problem. And my y is 2, and then I have to minus 2. So my final answer, I'll do it again in orange, for B prime, it's just a little hash, a little tick on the top right corner of your B, is 4 plus 3 is 7, and 2 minus 2 is 0. So that's my B prime. For my C prime, or for my C, I'll use light blue, medium-ish blue. So C, my point is 2, 2. So again, I'm going to write out my x and y, 2, 2. Arrow, okay, arrow, 2 plus 3, 2 minus 2. And I end up with the ordered pair C prime is 2 plus 3 is 5, and 2 minus 2 is 0. So that's my final answer. So once I do that, I can graph my new shape. I'm going to do it in orange, since that's what I did for my writings. So here, I'm going to do 5, 4. So I'm going to extend this real quick. Oops. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Somewhere around here. So that would be my A prime. And then my B, which is now 7, 0. Oh boy, here we go. 5, 6, 7. So that's 7, 0. So that goes here. That is my B prime. And then I have 5, 0. 1, 2, 3, 4, 5. 5, 0, which is my C prime. And then I connect the dots. So this triangle is now the image of my original shape. This is where my triangle is now after a translation. All right. So now we're done with that. If you have more questions, I can do more practice problems during office hours. This can be a little bit confusing when you first start off, so please feel free to ask questions. Next, the next kind of transformation that we have is called reflection. Reflection, also known as flip. It's exactly what it sounds like. You are flipping from one side of the graph to the other side of the graph. For the purposes of this class, we will only be doing 2 types. Technically, there are an unlimited amount, but I will only be holding you accountable for 2 types. And for me personally, this is the easiest one because the steps are essentially just two steps. You'll see what I mean. So the first step to do here is, again, identify your vertices and label them. Yeah? Let me make sure that this says vertices. So if I use the same graph, maybe not that exact graph. If I use the same graph, so I have, I don't know, I'll make a new triangle. I'll put it on this side. So 1 point there, and then maybe 1 point over here, and then 1 point over here. Why not? So this is my shape. This is my 3 points. And I'm going to connect them. So let's say this is the shape that we're given. My first step is to identify and label my vertices. So over here, I'll label this one A, because why not? What sticks out more? I think red sticks out more. Yeah. So this is my my A here has the point 1, 2, 3 negative. Remember, because left is negative, and then down 1. So that's -3, -1. That's my A. My B here is going left 1, so that's -1 for the X, and down 2, so that's -2 for the Y. So B is -1, -2. And here I have my C, which is 1, 2, 3, 4, 1, 2, 3. So -4, -3. All right? These are my points. I labeled them. Step 2. Too big. So for my step 2, I'm going to be using one of 2 equations. Use one of 2 equations. And this is kind of be similar to the ones that we had for translation, but instead we're doing it with different equations. So this is what I mean by that. We're still going to have our xy. Xy does not change. This is the beginning of every single transformation equation. If you're flipping vertically, so what I mean by vertically is you're flipping upwards. So it's here, now it's here. Here, now it's here. So right here, if you're flipping vertically, it will look like this. X, -y. And so what the official term for this is reflecting over the x-axis, and I'll fix that. So we're flipping over the x-axis means that exactly what it sounds like. You take your x-axis, which is this horizontal line here, and you flip over it. So imagine that this is a wall, a fence, a line, whatever, and you flip this over it. It will be an exact mirror of the original drawing. The second way to do this is reflecting over the y-axis. And this is represented by the equation. Give me one sec here. X, y, -x, y. Now, here's something important. When I say negative y, I don't mean the y is always going to be negative. What I mean is, if we remember from when we were dealing with equations, negative y or negative something really means negative 1 times y, or negative 1 times whatever. So whatever number you have, you just times it by negative 1. And I'll show you what that means. So again, we're going to do every single one of these point by point. I'm not really going to care about the lines. I'm not going to care about the rest of the shape. I'm only going to care about the vertices. So right here, right off the bat, I'm going to deal with A. As of right now, my ordered pair for A is negative 3, negative 1. And then I'm going to rewrite my equation. So, oh, I haven't flipped it yet. Let's say we are, well, actually I could still do this. Let's say we are reflecting over x-axis. Let's do that one first. So if we're reflecting over the x-axis, so let's say we're reflecting over the x-axis. This is our original point. So our equation is going to be this one over here. This is the same for every single reflect over x-axis. You don't need to change it up like you did over for translation, where it depended on where you're going. This is the same for every single reflect over x-axis. So we're going to have negative 3, negative 1, and then I put my little arrow. And now I just see what I did here. So my x stayed the same, so negative 3, but then I have to do negative negative 1. Because remember, it's negative y. If my y is negative 1, it's negative negative 1, which we all know means positive. So my A prime is going to be negative 3, positive 1. Yeah? So that's going to be that. Let me see if I can change the color of this. Yes, I can. I'm going to make it red. There we go. So that's reflect over x-axis. If I wanted to reflect over a y-axis, let me put a little line here actually to separate them. Perfect. Perfect. If I wanted to reflect over a y-axis, I would then use this bottom one over here. So again, I have my A. My A is negative 3, negative 1. That didn't change. And then I'm going to use the equation on the bottom here, because this is reflect over y-axis. Again, this is useful for every single reflect over y-axis. All you're doing is just plugging in different numbers depending on what point you have. So here I have negative 3, negative 1. And then I remember that my x is going to have the negative sign in front of it. So it's going to be negative negative 3 and then negative 1, because my y doesn't have anything there. So whatever my y was, I just plop it down. Which means that my A prime, for this specific one, I'm going to make this one blue. My A prime is positive 3, because negative negative is positive, and negative 1. Okay? And we're going to do this for B and C as well. So for B, I'm going to have negative 1, negative 2. And I'm going to be talking less during these steps because it's just a repeat over and over and over again. It's just so that you see kind of what the finished product is going to look like. And this is exactly what I expect your work to look like, this little 3-line math here. If you have this steps, you did all your work. So B is negative 1, negative 2. So I'm going to plug in negative 1, negative 2, put in my arrow, and I just fill in. So the x, because I'm doing x-axis, is just regular, so negative 1, and then it's negative y, so negative negative 2, which means that my B prime, let me use red again, my B prime is negative 1, positive 2, because it's negative negative, and the reason it's negative negative is because This equation says to put a negative in front. And then I have my c, which is -4, -3. And I'm getting all of these points from here, from this graph. I'm basing it off the graph. And I'm going to use the equation, so I'm going to plug in -4, -3, do my little arrow, and I know that it has to be, whatever the x is stays the same, but the y has a negative in front, so the x stays the same, and the y will have a negative in front, which means that my c prime is going to be -4, +3. So if I were to draw this out, and I'm going to draw this in red, it would look something like this. So -3, 1. So -3, 1. Let's see how high is this through here. So 1, 2, 3, 3. So -3, -1. So a prime would go here. My b prime, -1, 2. So -1, 2. This is where my b prime would have been, or will be. And then c is -4, 3. So -4, +3. And this is where my c prime is. So if I were to connect the dots, there's my new shape. And as you can see, it is a reflection of the original one. So let's do it again for y-axis. So I have b, it was originally -1, -2. My equation would be -1, -2, so just rewriting it, arrow. Now for the y-axis reflection, it's telling me that the x has a negative in front of it now. So it's going to be -1 and -2, because the x is supposed to have the negative in front of it now. So that means that my b prime is going to be +1, because negative is +2. Alright, let's do my c now. For my c, my points were -4, -3. My equation, just rewriting this point with the little arrow, and then I know that the x has the negative in front, so it's -4, -3. So my c prime is 4, 3. So let's see what this looks like. So I know that a prime is going to be 3, -1. So let me do this. 1, 2, 3, 4. So it'll be 3, -1. So this is going to be my a prime. My b prime is 1, 2. 1, -2. This should have been a -2, because this should not have changed signs. And that should also be a -3, because that did not change signs. So 1, -2, right here. That is my b prime. And then 4, -3. That is my c prime. And then I connect my dots. And there you go. That's my reflect over a y-axis. Again, it's a mirror image, just with a flip horizontally. And that's it for today. We will go over more practice problems of this on Tuesday, so stay tuned for that, and I will see you all later.